Today practical is resonance in LCR. The aim of this practical is determination of the resonance frequency, bandwidth and quality factor of the LCR circuit. And simply here is the LCR circuit. Today I am not going to explain you about the theory part. You can go through that one. And now we can move to the procedure. First step, open electronic workbench software on your computers and draw the circuit as given in this figure. For this one we need resistor, capacitor and inductor. We can take resistor, capacitor and inductor, and also we need function generator and CRO. From the instruments box we can find these two. Here is the function generator and here is the CRO. Now we have to connect this one. And we are using the CRO in order to find the voltage of the resistor across this resistor. So we have to connect this one here. Next we have to ground the circuit. Okay, now circuit is complete. Now next step, double click on the resistor, capacitor and inductor symbols and choose the values as R is 100 and here they give some values. Here you can double click this one, then you have to change this value as 100 ohm. This one 100 ohm, this one 0.1 microfarad. This one I think 0.16 Henry. Okay, now we have already put the values. Then double click on the function generator and set the applied voltage as 1 volt. This is the function generator. When we double click in this one, we showed the window like this. Then you have to set this one, the applied voltage as 1. Here you can see that amplitude bar. In this bar you have to change this one as 1 voltage. Connect the CRO to measure the voltage VR across the resistor that is proportional to the current, and measure the voltage VR with frequency in the range 500 Hz to 2 kHz. Here we have already connected the CRO across this VR, and first we have to input 500 frequency. In the function generator box, here the bar as frequency, then you have to change this one into 500 Hz. Then double click on the CRO and expand the window. After input the corresponding frequency, switch on the power button in right side corner of the screen. Okay, the next step is you have to double click on the CRO. Then the window is expand like this, and here is the button of start, and now we have already set all the values in the function generator as well as these tools. Now we start to run this one. Here you will see the wave is coming. So what you have to do is you have to use this red and blue line exactly in half of the time period. That means your frequency is 500 and time period is equal to 1 over f. Here is the one time period, but you have to take the values for half of the time period, exactly here. And now I put on here frequency is 500. Your half of the time period value is this one. Don't consider about this -1. Here there is a phase change, but we are not considering about that phase change, therefore neglect that one. And here is the value for your VR. In the PDF copy, they have already given that table. In your copy, I think this one is mentioned as VRMS. Please change that one as V peak to peak value. Then you will get the wave like this. Already we have find that the half of the time period, what is the voltage value. Here you can see the voltage value. This one is peak to peak value. In the table for 500, put your voltage value, and then you have to convert that one into VRMS value using this equation. And then using the equation of V is equal to IR, you have to find the IRMS value for IRMS value with the help of this VRMS. Here, according to this example, for 500 Hertz, we have already found the value. Here, we peak to peak value. This one microvolt. In here, I use this one as volt. This is the value for 500. And VRMS value you have to calculate it by using this equation. The VRMS value is 0.0537, and using this equation you can find the IRMS value. Here R is we have already put as 100 ohm. VRMS value is 0.0537. You have to divide that value by 100. Now you can get the value for IRMS. The next step is you have to repeat these steps to 600. What you have to do is, in the function generator box, change the frequency as 600, then run the program. Now you have to take the value for voltage. Here your voltage value is given as this. This is micro voltage. You have to take this one as voltage. This one is in voltage 0.197. Then you have to repeat the same procedure. This one 0.19 0.19798. Here value is 0.19798. You have to convert this one into VRMS value using this equation, and after that you have to find the RMS value, IRMS value. Likewise, you have to take this one up to 2000. I'll do more examples. Here we will see 900. In function generator, change the frequency value as 900, then run the program. Now you have to take the voltage value. Now your voltage value is given as 469.8348. You have to follow the same procedure. Find this is your V peak to peak value. Find the VRMS value and IRMS value. These two you have to calculate it. This one is your reading. These two you have to calculate it. Likewise, you have to continue this practical up to 2000. Now you have to draw the graph I versus F. Here IRMS value we have already found. Here you get some set of IRMS values. By using these values and these frequency values, you have to plot the graph I versus F. Here I versus F graph you have to draw, and then you have to select the maximum value for I. That one we taken as I naught. Select the maximum value of I naught and divided that in square root of 2. Then you have to draw the line and select the value for F1, F0, F2. Here F0 value means the frequency value of the I naught. That means maximum I value is I naught. That frequency is we taken as F0. Then you have to find this F1 and F2 using this I versus F graph. Here plot IRMS against frequency and obtain resonance curve and calculate the resonance frequency, quality factor and bandwidth, and compare these values with theoretical calculations. In the theory part, they have already given the equations for quality factor and bandwidth and resonance frequency. This is the equation for quality factor. You can find this one with the help of F0, F2 minus F1. So this is the VB2 minus VB1. That one simply given here. What you have to do is you have to carefully correct the half of the time period here and here. Correctly you have to take the half of the time period and you can have the value for VB2 minus VB1. Okay, if you have any question, you can directly contact me through WhatsApp. And this is the end of this practical session. Thank you for engage this one.